So this is a video on how to solve rational equations, and rational equations are more or less just equations that have fractions in them. If I wanted to be a little bit more explicit, there are equations that have fractions, and there is likely to be variables in the denominator. Okay, so we're going to do this using these 4 steps. Now there are slightly different ways to handle it, but if you're feeling a little shaky on solving rational equations, then it's kind of nice to have a set group of things that you have to do. So this provides just that. As you are getting more confident on solving them, these 4 steps will work. Okay, so we're going to do this with an example. So the example we're going to use is example 1, 4 over x minus 5 plus 2 equals x. Let's write that a little neater. Equals x minus 1 over x minus 5. Couple things to keep in mind. Remember that fraction bars are actually grouping symbols, meaning that anytime you have a fraction bar, there's automatically parentheses around any adding or subtracting the numerator and the denominator. So there are invisible parentheses here. And I'm just going to make them visible, and I'll even do it in a different color to notate that I added them. They weren't there originally. So you'll see a problem like this, and you have to know that there are invisible parentheses because they won't provide them for you always. Okay. Now, step 1 to solving these equations is to find the LCD, otherwise known as the least common denominator. So that means I'm going to look at every denominator in the problem for each term. So here's one term. Here's another term, and here's another term. And there's only one denominator in this problem, so that makes the least common denominator just x minus 5. So that's going to be my LCD. Step 2, I'm going to take that LCD and I'm going to multiply all the terms by that least common denominator, or LCD. And the goal of this multiplying is to cancel out all the denominators, because what's making this equation look hard is that it's in a fraction. So if we multiply by the LCD and cancel out all the denominators, that's going to solve that issue. So we're going to go ahead and do that. And I'm going to do step 2 down here so that we have a little more space. I'm just going to rewrite the problem. And again, I'm making those invisible parentheses visible. Because it will make it easier to remember that x minus 1 counts as one number or one expression. X minus 5 counts as one number or one expression, so that you can't separate it out for this part of the problem. All right, so I'm multiplying this whole fraction by x minus 5, the LCD. So that means that has to distribute to each term. So I'm going to multiply that x minus 5 times this term, and this term. So it's going to go to every single term in the problem. So I'm going to go ahead and write it out 3 times instead of only once, so that I don't forget that. So that gets multiplied by x minus 5. This gets multiplied by x minus 5. And this gets multiplied by x minus 5. Now remember that x minus 5, any number is really itself over 1. And even if that number is an entire expression, remember x minus 5 counts as one number, even though I don't know what it is. If I subtract x minus 5, I'll get one number. So that is the same as itself over 1. So when I multiply by x minus 5, I'm really multiplying by x minus 5 over 1 when it's a fraction. So I can cancel out the denominator and the numerator. And then this first term ends up being a 4. The second one, nothing cancels out. So it's just plus 2 times parentheses x minus 5. And then this term, the x minus 5s are going to cancel out, so you're just going to be left with x minus 1. Okay. This now is a much easier equation to solve. So then we get to step 3, which is solve the equation. Now, to solve this, we have to first simplify it. So I'm going to do that by distributing the 2 here. So 4 plus 2x minus 10 equals x minus 1. And I'll drop the parentheses now because I don't need it anymore. Because this is a linear equation, we're going to go back to algebra 1 and just move all the x's to the left side. and all the numbers to the right-hand side, okay? So I'm going to subtract x from both sides to move so that there's only an x on the left side. And then I'm going to add the 4 and the minus 10 because those are like terms. So that's x minus 6 equals negative 1. And then I'm going to add 6 to both sides and x equals 5. Now, usually we would be done because we would have solved for x, and that's what they're asking for. But with a rational equation, there's an extra step that gets added, and that's step 4. And we'll read it, and then we'll talk about it. So step 4 is if there is a variable in the denominator, then find the restrictions on the domain. Cross out any answers that are restricted from the domain. These are called extraneous solutions. So basically, if there is a fraction, you're not allowed to have 0 in the denominator. So if the number that you find makes a 0 in the denominator, it won't work anymore because it makes the problem undefined. So that just means it's impossible. So if there's a variable in the denominator, then that's going to possibly cause a 0 in the denominator. So we're going to have to actually double check. So we're going to go back to the original problem. And there was in fact a variable in the denominator. So that's going to be something we're going to have to check. So remember that the denominator, the domain, is restricted because you can't have this denominator equal to 0. So I'm going to go ahead and do check this 2 different ways. One is I can just plug 5 into the equation and see if a 0 happens in the denominator. So I'm going to copy the original equation. So this is step 4. Checking the domain. And one way to check the domain is to plug x equals 5 into the original problem and see if it causes a 0 in the denominator, which is a problem. Let's say it causes denominator to equal 0 to be more precise, which is not allowed. Okay, which is not allowed. Okay. So I'm going to take the original equation, which was 4 over x minus 5 plus 2 equals x minus 1 over x minus 5. And I'm going to plug in the 5. So that's going to be 4 over 5 minus 5 plus 2 equals 5 minus 1 over 5 minus 5. Well, immediately here, 5 minus 5 is 0. That causes a 0 in the denominator, so I can stop right there. That x equals 5 can't work. It's an extraneous solution, meaning a solution you get that doesn't actually work because it makes the problem undefined. So x equals 5 is an extraneous solution, which means that there are no real solutions. So because of step 4, this problem is no solution. And if I wanted to show my reasoning, I would say 5 is an extraneous solution, meaning a solution that doesn't really work. A solution that is an extraneous solution because it's not in the domain. Okay. So you may want to look at that again, but I'm going to erase that and show you a second way to check the domain also, because that's not the only way. Either of these ways is acceptable, whatever is preferable to you, okay? So we're going to check the domain a different way. It's not quite that. Can we just... All right. Let's go back to, we solved this and we got x equals 5. So then we solved the equation. That was step 3. And now we're looking at step 4. Again, we're checking to see, step 4 is to check the domain to make sure that x equals 5 actually works. This time, we're going to check the domain by doing it the old way that we learned in class. So this should be review. And that is to look at the original denominator in the problem, which was right here, and make sure that set every denominator in the problem equal to 0. So there's only one denominator because they're both x minus 5. But every single denominator has to be set equal to 0 or not equal to 0. Set every denominator not equal to 0 and solve. So the only one here was x minus 5 can't be equal 0. So I add 5 and I add 5. So x can't be 5. So my domain is that x, I'm allowed to have x can be any real number except 5. Well, the only solution I got was 5, so that's not allowed, that means. So because of step 4, there is no solution again. Because 5 is an extraneous solution, so it's not allowed because it's not in the domain. Okay. All right. Let's do one more example, because sometimes just seeing a different example helps you see it in a different light. Okay, so we're going to do how to solve rational equations, and the example we're going to use this time is example 2. Again, remember that anytime you see a fraction bar, there's invisible parentheses around any expression. So I'm going to make those explicit. You should know that that x minus 4 counts as one expression and x minus 5 counts as one expression. Okay. So then step 1 is to find the LCD. So we're going to go ahead and do that. This time there are 3 fractions. And the factors that I see are x minus 5 and x minus 2. So my LCD, or my least common denominator, equals x minus 5. Working on trying to figure out how to best use this computer and write on it. So I apologize for the sloppiness. Okay, so it's going to be x minus 5 times x minus 2, okay? Because it has to have both expressions or both factors in it, and then the other denominator already has an x minus 5 in it, so I don't need to put in another one. Step 2, multiply all terms by the LCD, and the point of this is to cancel out all the denominators, so I want to get rid of all the fractions. So we're going to do step 2. So I'm going to copy the original equation as neatly as I can and spaced out so that I can write out the LCD. And I'm going to make those parentheses explicit to make it easier to reason out later. I'm going to multiply this whole thing by x minus 5 times x minus 2. That means that x minus 5 times x minus 2, I'm multiplying it to the left side of the equation and the right side of the equation. So I'm changing the value of the equation, but by the same amount. So the equation is still equal. That means I have to do it to every single expression. So, excuse me, every single term. So that one has to be multiplied. This one has to be multiplied, and this one has to be multiplied. So I have to write it out 3 times. So instead of writing it once on the outside, I'm going to write it for once for each term. So I don't forget to do it for every single one. So it goes to the first term, it goes to the second term, and it goes to the third term. Again, remember that x minus 5 times x minus 2 counts as one thing. So you can put it over 1, and it's the same thing. Anything over 1 it's the same as itself. So if I want to just make that explicit that it's a fraction, I can do that. This will cancel out. This will cancel out. And then I get left with 3. And this is the solving. This is step 2. So 3. And then here, nothing gets canceled out because there's no denominator. So it's just going to be 2 times x minus 5 times x minus 2. Here, the x minus 5s get canceled out. So it's x minus 4 times x minus 2. Okay. Step 3 is solve the equation. So at this point, there's no more fraction. That's what made this problem look really hard. So now I can solve it. So we'll do step 3. So I'm going to first do this part right here. X minus 5 times x minus 2. So I'm going to distribute x times x is x squared. X times minus 2 is negative 2x. Negative 5x plus 10. Combine like terms. So it's x squared minus 7x plus 10. And then that's still in parentheses, and I still have to multiply it by 2. So in fact, it's going to be multiplied by minus 2. So I'm going to just bring down that 3 and do negative 2 times x squared is negative 2x squared plus 14x minus 20. And that's going to be the left-hand side. The right-hand side, again, I'm going to simplify. So FOIL, so x squared minus 2x minus 4x plus 8. And you might want to just pause the video here and see if you can solve the rest on your own. And in the meantime, I'll go ahead and solve this, assuming that you've done that if you want to. So I'm going to combine the 3 and the negative 20. I'm going to combine the negative 2 and the negative 4 on that side. Okay, so those two went together to be the negative 6x. All right, and then the 3 and the minus 20 was negative 17. All right, so now I need to move, because there's an x squared, guys, this is not a linear equation, so I can't do it like algebra 1. I need to move everything to one side and set it equal to 0. So some of you will make the a clever move and add 2x squared to both sides. You can do it either way, guys, but I'm just going to do it this way because I like having a positive first term. So that's going to become 3x squared, and that's going to cancel out. Subtract 14x. I'm trying to get a 0 on this side, by the way. So I'm getting rid of the 2x squared, so I'm getting rid of the 14x. So that's going to be minus 20x, and I'm going to get rid of the 17. So I have to add 17, and that's going to be plus 25 equals 0. Okay. And then I'm going to factor. So when to solve a polynomial, I set it equal to 0, and then I factor. Factoring, I have to look for a GCF. There is no GCF. So I'm going to do it the 7-step way, where I multiply 3 by 25. In fact, I'm going to multiply 3x squared by 25. And I'm going to do it in a different color. So that's going to be 75x squared. And I'm going to look for two things that multiply to 75, positive 75, but add to negative 20. Because they add to a negative number, guys, I know for sure that, they can't both be positive. So I'm going to just skip straight to the negative. So they both have to be negative. Well, that's going to add up to negative 76. So it's too big. Negative 2 doesn't work. I'm going to just jump. Negative 3 does work, but for 75, but it doesn't add to negative 20. So 4, 5, and 15, I believe. And that looks like it's a match. It multiplies to 75, and it adds to negative 20. it also has to multiply to 75x squared, not just 75. So I'm just going to include the x's just for the correct pair. So negative 5x times negative 15x multiplies to 75x squared and adds to negative 20x. So that's the right pair. So now the next step is to rewrite the original problem, but I'm going to replace the negative 20x with my new pair, which is minus 5x minus 15x. Reminder, this pair always is the same value as negative 20x, so I'm not changing this expression, right? Because negative 5x minus 15x is negative 20x. So because of that, I'm not changing the value of this entire expression. I'm not changing the value, okay? I'm just making it into 4 terms instead of 2 terms because it turns out it's easier to factor that way. All right, so then I'm going to split this into 2, and I'm going to, for each half, I'm going to take out the GCF. So the first half, the GCF is x, and then what's left is 3x minus 5. The second half, the GCF is minus 5. And when I pull out a negative 5, I'm left with 3x minus 5 because I have to change the sign since I pulled out a negative. I'm going to rewrite it so that 3x minus 5 only appears once, and the GCFs go in front, which is x minus 5. Okay, so I've now factored 3x squared minus 20x plus 25, and that's exactly the same thing as x minus 5 times 3x minus 5. But the factored form makes it easier to solve because if this equals 0, then each of those terms is going to equal 0. So x minus 5 equals 0, and 3x minus 5 equals 0. To solve, I add 5 to both sides. So x equals 5 is going to be one solution. The other one, I'm going to add 5 to both sides, and I'm going to end up with 3x equals 5. So I have to divide by 3, and I get x equals 5/3. So I've got 2 answers here, x equals 3 and x equals 5/3. X equals 5, excuse me, and x equals 5/3. Again, you would usually be done here except for rational equations, or from now on, we're going to actually have to check if there's a fraction. Step 4, check the domain. Does that actually work in the domain? All right, so I'm going to do this only one way, which is to check the denominators of the original problem and see if any of those values makes the denominator equal to 0. So I'm going to solve for the domain, which is to set the denominators equal to 0. So because I'm running out of space, I'm going to have to erase all this, but hopefully you can pause the video if you needed to see it for longer and view it that way. So select a whole bunch of them so I can erase all of this in one go. All right, so we did step 3, and we got x equals 5 and 5/3, and now we're doing step 4, which is to check the domain. Check domain. And we're going to do that by setting each denominator not equal to 0. Okay. So my first denominator was x minus 5 times x minus 2. So I'm just copying it from the original problem. X minus 5 and x minus 2 cannot equal to 0. All right, so that means that it's already factored. So x minus 5 cannot equal to 0, and x minus 2 cannot equal to 0. Add 5 to both sides. So x cannot equal 5. Add 2 to both sides, and x cannot equal 2. The other denominator up here in the original problem was x minus 5 by itself. Well, that's going to end up with the same answer as the original problem, but I'll go ahead and do it just so you can see that. So x cannot equal to 5, but I already wrote that down, so I don't need to write that again. So my domain is x can be any real number except 2 and 5. So then I look at my solutions and see, well, x can't be 5 then. So I have to take that out. That's an extraneous solution because it doesn't work. So the only solution that actually works is 5/3 because x can be any number except 2 and 5. So it can be 5/3. Okay. So that means that my final solution is x equals 5/3. And if I wanted to be explicit, it would be x equals 5 is an extraneous solution, meaning it doesn't really work. It's an answer I get that doesn't work.